right, so hello everyone. Thanks for having me. My name is Dan Brown. I'm here to present a project that I've been working on, just a little part of it. It's motion sensing for the application of sleep. For those of you out there looking to monitor, this could give you some ideas. So this is some data from the application that I worked on. What I wanted to do was track my sleep because I didn't know what I was doing while I was sleeping. I started out by filming myself, and I noticed that I moved around a lot more than I expected. So I wanted to dig into more details about that, and looked into a couple of devices out there. I'm sure you guys have heard of Fitbit and Zio and some others like that. And so I cooked up my own device that uses this microphone as a pressure sensor. It's hooked up to an air mattress, and then it feeds into a Linux box, which runs some software that I wrote. And so motion, you can talk about motion in a lot of different ways, but the microphone's sensitive enough to pick up a couple different types of motion, and they're in different frequencies and with different magnitudes. And you can see, by motion I mean like somebody rolling around on the bed or moving their arm or that kind of thing. Snoring is obviously a type of motion that's more in the sound frequencies, and then heart rate is something that requires a bit of more careful analysis, but it is possible to get heart rate at some points. And so you can see this is me overnight. I wasn't in bed there. I got in bed, and you can see how things changed over the night. You can see that I did have a couple snoring episodes there. Other people who know me might recognize that as something that I do. So one of the things I'm trying to do with my application is figure out what factors go into that and hopefully reduce that from my behavior. But this is all I'm going to show you from the sleep data. I'm going to go more into talking about the microphone and the analysis of the data that comes from the microphone for this presentation. So microphones are pretty amazing things. They make a couple billion of them every year these days because they put them in pretty much every cell phone, and they actually have a couple in modern cell phones for noise canceling and other things. They're really pretty cheap, and they're pretty tough too. These have been around for a long time, and they work in a way that's a little bit similar to micro machined accelerometer, but they're older and a little bit tougher. So I just got mine from DigiKey. You can do that too, and then just wired them up straight into this device, which is a USB sound card. Obviously, the microphone and the sound card are optimized for the frequency range of hearing, which is about 20 hertz to 20,000 hertz. And some of the motion that I'm interested in recording is less, is a lower frequency than that. So I needed to make some modifications, like the thing on the right, to change it so that it wouldn't get rid. Because when you're working with sound, you don't really want very low frequency waves. They're interference. But if you're working with motion, you might be interested in some of those. So after some messing around, came up with this approach to modifying this cheap sound card. Then data analysis. Used a few tools that were really, really helpful. I've just chosen a couple here to bring up to your attention, but these three are all fantastic. Audacity is something that's what produced this waveform, which is 30 seconds of me walking, getting into bed, and then breathing and having my heartbeat show up. So the microphone is plugged into an air mattress. The air mattress is below the mattress. And I left it on just all day and night. So it gets more interesting because you can see these waveforms, but then when you want a system that is smart enough to get the real signals out of the data, you need to start attacking it with some of these analytic methods. So what I did was I started out with, this is not an invention of mine, I started out with a thing a lot like that, which you can get at like a camping store. That's my able assistant. Yeah. So this is, it's easier to see, but this is like what you might call a thermarest or a self-inflating air mattress. This one happens to come from China. It was a sample that I got. And the air moves when you move. It's as simple as that. And the pressure sensor just plugs right in here. It has a slow leak so that over time it'll equalize.
You mean the microphone?
Microphone, yeah. Same thing. Yeah.
Microphone's double clear.
Yeah, take us through
Good
that.
point. Good point. So there's a microphone goes in here, and it does changes in pressure. You're absolutely right. And it's a question of how low you get that cutoff threshold. And then that would go straight into the card that I showed you before, and you'd run, if you were recording, like a memo or something like that, similar kind of software to that, and then I would do some post-processing.
So the microphone, just to be maybe stupidly clear, the microphone works as a pressure sensor because it hears the air expelled from the mattress. That's basically,
That's right.
That's the actual
Yeah.
sound waves that are being, that's what a microphone does.
So
right?
this thing that they've labeled front plate diaphragm is flexible. It's a sheet of mylar with a charge on it. And so as that moves, it induces a voltage in this black back plate, which then gets amplified and sent to the output.
And you did modify the microphone, but you did modify the USB chip. Was
That's
that
right.
like a hardware modification, or was it just a software modification?
Hardware, but very simple. It was finding that one capacitor and soldering on another capacitor piggyback on top of it to make it.
How did you know that that was the capacitor too?
Well, so this drawing is from the manufacturers, so you can see who makes the chip, you see the model number, you can see the manufacturer's reference design, and then you just follow the little leads.
So, some questions, okay.
So I'm curious, for detecting movement, why did you choose a microphone with a pressure sensor versus, say, just having an accelerometer on the body?
The reason I chose that because I didn't want to wear anything to sleep, and I didn't want to turn it on, and I didn't want to have to remember to charge it up or anything like that. So this thing's plugged into the wall, and I don't have to.
Does it only work if you have an air mattress? If you have a normal mattress with coils and all the things they
Oh,
advertise?
sorry, I should have made that more clear. I have a regular mattress. I bought it at Costco. Bought, springs and everything. And then the air mattress goes under, like between the box spring and the top mattress.
How big is your air mattress?
It's about like, well, you mean
So
like.
this is it? It's
So,
safe,
no,
right?
this isn't that.
Oh,
This is
it's
not
not.
it. This is a sample. It's about 4 feet long by like 2 feet wide. You can use whatever you can fold under that. You can fold up the end.
Is it fully inflated or partially? Or?
I just let it self-inflate.
Have you ever tried using a piezo sensor as opposed to a microphone and attaching that kind of directly to the mattress?
So the question is,
The question was, have you tried using a piezo sensor? I have not. I've used some other similar sensors to that, but I haven't used piezo.
okay, so Mark,
Could you describe your data? I'm interested in how many days you're looking at, and just for a stupid question, how much data per day? How many kilobytes or megabytes or per day?
So I have data going back more than a year, probably about to the start of 2009, or before. Lately, I've only been looking at it on a day-by-day basis and kind of flipping sheets. That's just how I have the reporting set up. But I could look at trends over time. I wasn't going to plan to talk too much about the data in this, but it is relevant. The most interesting data I've got from this so far is the heart rate data. I know that I move around and I can see some trends in there, but when heart rate goes up for me, like my usual resting heart rate is like right around there. It's like 50, 40, or high 40s, mid 40s. But when it goes up to the mid 50s, that means my body's working really hard. I could be sick, I could have allergies, I could have, attacked my body in other ways that day, and that'll definitely show up. And what's interesting is that's the first indication that I need to look after myself. It comes before any sort of like stuffy nose or any sort of like headaches or any sort of things.
And the mattress is picking up your heart rate?
Yeah, it's very sensitive. Microphone's very sensitive. It doesn't pick it up when I'm moving, obviously, right? That just swamps all the signal. But when you're still up to.
Can you talk about your process for how you looked at the raw data and made sense out of it, what the different...
To get to this?
Yeah.
So you saw the data before, right? And if you can imagine the part on the right where you see, kind of more waves. What I do, it's different for each of these. For the motion, I do a Fourier transform and do a power and a spectrum. The frequency range that I use is 5 to 25 hertz.
And what was the process in getting to understand...
How to decide that?
Yeah.
Eyeballing it, just looking at it over time. I mean, I could sort of correlate what I knew to be movement with what showed up and what was sort of easy to see. Snoring was 50 to 100, and then the heart rate was an autocorrelation. The thing is so cheap, it only records at 48 kilohertz, but I don't want that much data. I downsample, resample down to about 2,000 hertz, and then I use that in the Fourier transform for different things. But you can kind of see some quantization in the heart rate because I have a lower sampling rate, so I only have so much precision.
Did you do any calibration, or you just put the new capacitor in and you get your guesses of the frequency range were right and it just worked out of the box?
Pretty much. I mean, you can do some validation, like I have a chest strap heart rate monitor that I can wear, and I can compare the data from that. So yeah, it makes it's, and you can also just measure like that. It's pretty obvious. Like, yeah, I guess this data doesn't really show it that well. I could zoom in, and you'd actually see like it rings, but you do see a repeated pattern in each heartbeat.
You're on the right slide. I know Audacity and SciPy. Pratt?
Yeah, this one's more obscure. So these are all open source. Pratt is a linguistic software analysis package out of the University of Amsterdam, I think. It's really good, and it's programmable. If you just search for it online, that'll be the first thing that pops up. And that's what you can do a lot of good stuff.
The big stuff is what your linguistic.
So they use it for telling the difference, like the academics that did it, use it for analyzing like accents or speech recognition or speech impediment issues, like those kinds of things.
And how are you using it?
I use it for exploration. I don't use it actually in my pipeline. And so I was looking to see what the dominant frequencies are there and which ways of analyzing would actually.
Can we get one more question here? Yeah.
Do you leave this on during romantic use of the mattress? If so, what kind of data do you like?
Is this left on during romantic interludes? Yes, well, it's always on. So yes. What you see is actually, it looks a lot like this, which is when you're hopping in, like it just gets peaked out, right? I suppose you could reduce the magnitude and see those. And in fact, there was a Twitter project where a buddy went on his honeymoon, and his best man played a prank by hooking up a machine a lot like this to the bed, and it would then tweet every time it detected any some commentary. I don't know what happened to the picture, but so that's one thing that I probably should just end on, and it's a negative note, unfortunately, and that is the reason why I stopped doing the project. Is this works great when one person's in the bed, but when two people are in the bed, I had a very difficult time. I was hoping I could use some methods to separate the signals with different sensors, but I wasn't able to. So that's what stopped this one.
What did you